attendees. Okay.
On racing boats is kind of one of my core competencies. It's one of the things I do a lot of. And I've done it at all different levels of yacht racing. Essentially, you know, what I want to start with is like the why of instrumentation on a sailboat. You need instrumentation to gauge your performance because it's the only real gauge you have, particularly in an ocean race. If you're one design sailing and you got a boat right next to you, well, that's fine. You can see if you're higher, faster, or whatever. But when you're in an ocean race, the only thing you have really to gauge your boat is your instrumentation and how you're progressing against the wind and the waves and all the rest of it, how fast you're going to get to where you want to be. In developing your polars, you know, I'm assuming everybody understands what a polar is. You know, it's basically describes how your boat sails on any given point of sail in any given true wind speed. And it's a very important thing for ocean racing. When you start to do routing and expedition, the core thing that's in there that makes that routing possible, well, there's two things. There's weather files, and then there's the polar. And that's essentially how that routing works. So the polar basically describes how the performance of the yacht, it describes the performance of the yacht in any given wind speed, in any given true wind angle. And in order to develop a polar, you have to use instrumentation, and your instrumentation has to be accurate. And if it's not accurate, then it just isn't going to work right. You know, it's the whole garbage in, garbage out kind of thing. So that's the reason, that's the value that instrumentation is going to provide for you to have on your boat, is that you can have some sort of gauge to figure out how well you're doing, and you can predict how well you're going to do in the future, and you can do routing. There's several different types of instrumentation that's commonly found on sailboats. I'll start with the less expensive kind of entry-level systems, and then talk our way up to the more higher Grand Prix type instrumentation systems. So there's these kind of cruising systems, mostly Ray Marine, Garmin. B&G has some kind of entry-level systems. They call it Triton system. And those entry-level systems, the biggest thing that separates them from the more sophisticated ones is the ability to calibrate them. The entry-level Triton systems and Ray Marine Garmin systems don't have the ability to calibrate them beyond, say, you can swing the compass to get deviation out of your electronic compass. You can calibrate your boat speed to adjust, you know, to make sure your boat speed's accurate, and you can adjust your apparent wind angle offset so that the apparent wind is symmetrical from side to side. And that's pretty much it. Yeah, and a lubber line offset for your compass, so like a heading offset. So if the compass isn't mounted perfectly square in the boat, you might be able to put in a little bit of an offset correction for that. And what you'll find with those types of systems is that when you go out and you tack your boat, let's say you're looking at wind direction, and the number on the wind direction is, you know, 235, and you're on port tack, and you tack over to starboard, and you generally have to wait 30-40 seconds for your instruments to kind of settle back in on the new tack. But then you look at the number and it still says 235. That's good. I just got a message popped up on my screen, said my internet connection is unstable. I just want to check in with you, Corey, to make sure that it's working. Can you hear me okay?
Yeah, you're occasionally a tiny bit choppy, but I think all your words come through eventually.
All right.
So steam ahead. I'll interrupt you if it
Okay,
becomes difficult to follow, but so far so good.
all right. So essentially what can happen is that your true wind angle. So all these computers are really doing is resolving relative motion. So they're taking the motion of the vessel out. So you have these transducers that sense the apparent wind on the boat. Then the computer says, okay, well, the boat speed is, 8 knots. So then they take the movement of the vessel out to resolve what the true wind angle and the true wind direction is, and the true wind speed. So there's no real way to correct errors on these entry-level systems. They're going to have errors. Go out and try it. If you have one of those entry-level systems, just go out and tack your boat a few times. When you think the wind is really stable, and see what the wind direction does from tack to tack. And it may be the same from tack to tack, but chances are it's not going to be, because in all of the sophisticated systems, we use correction tables to correct for the errors. And those correction numbers cross 0 at some point, which is generally between 10 and 15 knots. So if you happen to be at that point where that correction value would be crossing 0, then it'll work fine. But as soon as the wind gets a little stronger or a little weaker, you're going to show a difference in the wind direction from tack to tack. And it's just simply because the true wind angle is incorrect. The wind speed can be a little off too. And then these are things that with these types of systems, you just have to live with it, because there's nothing you can do to fix it. So the next level up in the, instrumentation hierarchy would be like the race system. So the ones that just about everybody uses are like the B&G H5000. There's some Nexus, Occam, but Occam's pretty much out of business, but they had a sophisticated racing system as well. And these systems give you different methods. Most of them are all done with a table, but there's varying methods to correct for the errors in the true wind angle. And essentially any degree, like say 2 degrees of difference in the true wind angle is going to be a 4-degree difference in true wind direction when you tack or jibe. So that's what you're trying to do. You're just trying to get all that error out of your system so that you can really understand exactly how the boat's performing. These systems will have generally a table, and that table might be laid out. I use B&G as an example because there's a lot of other systems that follow the B&G model. You get 5, 10, 15, 20, 25, and 30 knots of true wind speed, and then beating, reaching, and running. So think of it as a matrix or a spreadsheet, and you got to put in correction values for each one of those intersections. And that's simply just a value that's going to force the true wind angle to be right. And the way that you figure it out is you just do a bunch of tacks when you think the wind hasn't shifted. And that's why you do a bunch of them, and you change that number until the error goes away. And that's how those systems work. And then the other thing is the Grand Prix system. Some people, you may find yourself, if you got an older TP52, it might have what's called the WTP system on it, or a Racing Bravo system, or Faro, or one of these more sophisticated systems. And these systems are very, very sophisticated, but they're not, you almost need to have somebody that knows what's going on to run it, because they're very sophisticated and very hard to run. And I've gone and replaced a lot of them off of older TP52s when they're maybe not campaigned at such a high level, and the owners want something that's a little more simple, so it's a little more easy to operate. We don't need to spend a lot of time talking about those systems, because if you have one and you need help with it, I'd be happy to help you, but most people push them into something a little more pedestrian that's a little easier to run. Most of the newer systems that are out there are based on this open architecture that's called NMEA 2000. And what NMEA 2000 does, it's a communication protocol between all the different instrumentation systems on your boat. Could be between a computer, could be between a chart plotter, it could be between a depth sounder, a heading sensor, a wind sensor, and it's a method for all of these different devices to talk to each other and play friendly. And it goes across manufacturers too. So that's what enables you to use one manufacturer's display with another manufacturer's transducer, with another manufacturer's processor. And it's a pretty noteworthy or pretty, monumental kind of development that came out maybe 10 years ago. Prior to that, everything was really, really messy to try and make it all talk together. And then this simplifies it greatly. So in any of your newer systems are going to have this NMEA 2000 based architecture. And that will enable you to, use other people's parts. If you want to use a, Furuno heading sensor with a B&G system, you can. And there's reasons that you would do something like that. But I'm not going to get into that either. Just wanted to kind of give everybody an overview of all the different types of systems. And now I'm going to talk a little bit more about calibration. And calibration is just extremely important. It's like, don't go out and invest a lot of money in getting all this equipment and then sail around with it and have it uncalibrated, because it's completely a waste of time. The data that you're getting is not going to be accurate, and you're just going to be wasting your time with it all. It's not going to work. So definitely want to encourage everybody to pay some attention to the thing, read the manual about the calibration, call me up, hire me to come out and calibrate your instruments if you want. But it's very, very important and very, very valuable to make sure that your instruments are calibrated. It's essentially just 4 raw inputs into these computer systems. There's the apparent wind angle, the apparent wind speed, the heading, and the boat speed. And by using those 4 parameters, the computer will calculate all the resultant variables like true wind angle, true wind speed, true wind direction. If you add cog and sog into the inputs, then you can also calculate set and drift or current. So all of those 4 raw inputs all need to be calibrated independently before you try and calibrate any of the resultant variables. And that's because if you're going out and you're trying to calibrate your true wind angle correction, but you have deviation in your compass, maybe you tack the boat and you think, oh man, the wind hasn't shifted, and I just did 10 tacks, and every time I tacked, I saw a 5-degree header. You would think you would want to adjust your true wind correction table by 2.5 degrees, but what if you had deviation in your compass and your wind table is actually right? Now you're getting 5 degrees of deviation in your compass. Okay, so you make that correction to your table, and then the wind shifts 50 degrees. Now you start tacking, and you get the same problem. Well, it's because at that one particular heading that you're at, you had 5 degrees of deviation in your compass. So you always got to start with those 4 basic variables and calibrate them independently before you try and do anything with wind tables and all this other stuff. The boat speed needs to be very well calibrated. The heading needs to be very well calibrated. Apparent wind angle offset is important to make sure you get that right first. Apparent wind speed generally doesn't need any kind of calibration. All of the apparent wind speed, all the wind speed transducers are factory wind tunnel tested, and they don't require calibration.
Peter, can you just tell us a little bit about how you do calibrate each of those variables, and
Sure.
what kind of day you might pick for your boat to go out and do that?
Yeah. So a typical calibration, you start with the boat speed and the heading, the first 2 things you start with. So then the very first thing you do is you swing the compass. And if you have more than one compass, you swing every single compass you have before you do anything. And it generally involves telling the compass that you're trying to swing it and then performing some sort of a circle or 2 circles or whatever it is. Every compass is a little bit different. And what that does is it just takes any deviation out of the compass. It doesn't set it up, like if the compass is mounted a little bit askew in the boat, which is the heading offset, it won't fix that. All that will fix is deviation, so that the number it gives you, if you turn 10 degrees, it'll give you a number that's 10 degrees different, not 5 degrees different. So that's all that's going to do. But it's important to do that first, because the way that I do boat speed calibration, and this is, at the end of the day, if your computer can calculate current correctly, then you've proven that your boat speed is accurate and your heading is accurate. And so I'll just pull up a strip chart of all the, boat speed, cog, delta, boat speed, SOG, heading, cog, delta, heading, cog, set and drift. And then I motor at, ideally, you want to motor like 2,800 RPM. You want to be at close to whatever the upwind target, let's say in 8 to 10 knots is, hull speed, if you will. You go for a minute, you turn around, you go for a minute the other way, and you average everything. And so if your boat speed reads, a tenth over going in the first direction, it should read a tenth under in the next direction, and it's because current. And you want to be in a place where you know where the current is. That Point Potrero Reach right outside Richmond Yacht Club is a great place to do it, because the current's either going in or it's going out. It's not going sideways. You just motor in and out 1 minute each way. You adjust the boat speed so that the boat speed error is the same over and the same under going the other way. Same thing with the heading. The heading might be like 1 degree to the right as you're going out. If you turn around, it's still 1 degree to the right, then you need to use your heading offset and move it 1 degree back to the left. Now it'll be right going out and it'll be right going back in. Sometimes it might be 1 degree to the right going out, 1 degree to the left going in which case you don't do anything, you leave it the way it is. And when you get it all done and you want to know it's right, you look at the set and drift number. And if the set and drift number, which is essentially the current, is correct, it'll read the same going both ways. If the boat speed is too high, it's going to look like you're always fighting some current. And if the boat speed's too low, it's going to look like you're always getting pushed by current, no matter what the current's doing, right? So that's essentially the details of how you calibrate boat speed and heading offset. And removing deviation is just done by the compass swing.
And how often do most boats need to go through that calibration process?
Yeah, another thing I need to mention too is you want to make sure your bottom is clean when you do this. And the reason is, to answer that question, you don't have to do it very often. You can just check it. If you want to check it, you can just go out and motor for 1 minute, go each way, and check your set and drift to make sure it's the same. And if it is, it will be. I mean, these things don't change. The heading sensors, if you install if you change the magnetic environment of the vessel, like if you put some kind of large ferrous object near your compass, it's going to cause an error in your compass. But when you swing the compass, really what it's doing is it's making compensations for any hard iron abnormalities or magnetic signature, or whatever. It's looking at the magnetic environment of the vessel and neutralizing it. So as long as you don't change the magnetic environment of the vessel by moving the compass or introducing some large ferrous object near the compass, you shouldn't have to swing the compass ever again. It'll be accurate for many, 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 many years. But at the same time, it only takes a few minutes to swing it, and you can't do any harm by swinging it too much. So it doesn't hurt to do it. I hope that answers your question. You really shouldn't have to do it more than once. But the other thing I want to mention though is the dirty bottom thing, because the boat speed paddles, there's basically two different designs. And I'm not going to go into the detail of it, but essentially they're nonlinear. And what that means is that's why I say calibrated at hull speed, because you're going to spend a lot of time at hull speed, and it's going to be accurate at hull speed. What you'll find though is that it'll probably read fast when you're going over hull speed. It'll probably read slow when you're going under hull speed. And if it's a planing vessel, it could read 20% high when you start planing. And the reason for that is that a lot of the sensors don't penetrate through the boundary layer. And when the boat's in laminar flow mode, as it is when it's in displacement mode, you have to actually compensate, you have to actually over calibrate it by 15 to 20% to make it read accurate. And then when the boat gets up on a plane and the boundary layer breaks down as turbulent flow mode, it'll read 20% over. And it's not a huge, I mean, there are tables you can put in to correct it, which I would suggest you do if you have a system that's sophisticated enough that have these tables. And you would just see it by looking at set and drift changes when the boat's planing and non-planing, because that's where it's really going to show up. You know, you're all of a sudden you're going to be like, you might be looking at your SOG and it's reading, 18, and your boat speed's reading 15 or 12. And it's because of that phenomena of, once you start up on a plane, your boat speed's going to read too high.
Wait, Peter, are you telling me that? Oh, sorry. Are you telling me
that reason is why you need to clean the bottom, because if you have any growth at all on your bottom when you go to calibrate your boat speed, it's going to exacerbate that effect of the boundary layer, because there's going to be more friction from all that growth, and the boundary layer is going to go out a little further. So everyone thinks, oh, my boat's going so much slower because I got this growth on it, and it does go a little slower. But what happens is your instrumentation reads much slower. So your boat's still going, your boat isn't really going that much slower, but your instrumentation is reading considerably slower. So just make sure that everything's clean. Also, the impeller type boat speed paddle sensor, pull that thing out and put the plug in when you're not sailing your boat. Like if you're going to do a 2-day regatta, you can leave it in for the 2 days. But if you're going to not sail your boat for 4 or 5 days, pull that thing out, because it just gets growth on it, and it just, you got to clean it. I mean, that's pretty basic. I think everybody knows that, but I just thought I'd throw that out there. Okay, so the next step of the calibration is apparent wind angle offset. And to do this, you want to be in pretty good breeze, and you don't want to be overpowered. So it's just, anytime you're doing calibration, you want to have the boat as close to race trim as you can, and it's always best to be a little underpowered than it is to be overpowered. To do the apparent wind angle offset, you pull up apparent wind angle on one of your displays. You go upwind, you get close haul, you get everything right, get it trimmed up the way it should be, and then you just squeeze up. Look for just a little bit of bubble in the front of the jib, and when that happens, look at the apparent wind and just kind of hold the boat there for just a second or two, with the very front of the jib just starting to get a little bubble in it. Note that number. Tack, get the boat up to speed, get everybody hiking, get it all set up, do the same thing again. Just squeeze a little bit, look for a little bit of bobble in the front of the jib, look at the number. If the number is not the same, you need to adjust the apparent wind angle offset. It's a value in your system. Every instrument system's different, but generally, I think every single one of them if you make the apparent wind angle value more positive, it makes starboard tack wider. So if starboard tack is reading 2 degrees wider than port, you would make this, whatever the number is, you would make it one less. So if it's a 3, you'd make it a 2. If it's a 2, you'd make it a 1. So that'll narrow the starboard tack 1 degree, and it'll widen the port tack 1 degree, and now they'll both be the same. And that's pretty much that's the basic start of the calibration. Then you move into working on the wind table, and doing that involves tacking the boat upwind. In generally, you'd have to do it in a couple different wind speed ranges. You know, I like to do it in like 10 and then maybe 20. If I can do it in 10 and 20, I can extrapolate all the other values and get pretty close just in a 1 day kind of session. But I also tell people it's more like a grooming process because of the nature of the way they've done this, laying it out in this table. You're not going to be able to just go out and go, oh, it's blowing 5. You know, we'll run through all this, and then next day it'll be blowing 10. We'll do it in 10, because that just never happens. So you do it, you ought to calibrate, maybe it's blowing 7. So you gotta change the numbers in the 5, you gotta change numbers in the 10. And there's, you know, having a little bit of experience and knowing how the slope of the numbers kind of go is helpful. But I don't think any of you have that. But like I say, it's just a grooming process. You're gonna do this. You're gonna have to keep doing it, unfortunately. You can get it pretty good within 2 or 3 days, and you know, have some good numbers. But it's something you always want to kind of keep track of. You know, I mean, every time I tack a boat, I'll look at the true wind direction and look at what it does on the other side, and then try and figure out, well, did we really get a lift? Did we really get a header, or is that miscalibration? The other thing I should mention too is the apparent wind angle bearings in the anemometer, or the anemometer bearing and the apparent wind angle bearing generally is a 2 to 3 year replacement item. It's relatively inexpensive, and when it starts to wear out, your instruments start to read weird numbers. So if you haven't replaced the bearing in your anemometer, I would, in 2 or 3 years, I would suggest you do it. Just do it every 2 or 3 years. Let's talk a little bit about heel and leeway calibration. I mean, heel calibration is real simple. You just zero it out. For the most part, all the heel sensors, you don't have to worry about a span like, oh, it's 30 degrees this way, 30 degrees that way. You just zero it out and the sensor is correct. No, you don't need, somebody just asked if you need to recalibrate after replacing the bearing, and the answer is no, because the bearing isn't really the apparent, the bearing is part of the apparent wind speed, but we don't calibrate apparent wind speed because it's basically wind tunnel calibrated. And that's why you need to replace the bearing, because when the bearing wears, there's no way to just calibrate out that you got a worn bearing. You just have to replace it. And the angle bearing is kind of isolated from the actual sensor. It's just it doesn't affect the calibration. Back to heel. Heel is used in a lot of systems. Some systems don't use heel, like the cruisier systems don't use heel to calculate leeway, but your basic B&G system will use heel to calculate leeway. And if you don't have a heel sensor, then it can't calculate leeway. And the reason you want to calculate leeway is to get a more accurate current set and drift calculation, because the calculation for set and drift is the vector difference between the boat speed and the course, and the cog and the SOG from the GPS. The course is defined as heading minus leeway. So if you can't calculate leeway, you just use heading. And what you'll see is you'll always have a change in the set and drift, or the current calculation. When you look at current, it's always going to change from tack to tack in a boat that can't calculate leeway, because the boat's making a leeway 3 to 5 degrees probably. So it doesn't have the ability to take that out of the current calculation. And that's essentially, that's like the last thing that I would calibrate on a boat. Like, I'd get all the other calibrations done, and then I'd start working on leeway. And if you have a B&G system, the leeway coefficient should be between 9 and 11. And just about every boat I've ever sailed on ends up being between 9 and 11. You know, you could put it at 10 and you'd probably be really accurate. Some boats you might want to change it, but if everybody here puts theirs at 10, you'll be in good shape. What else?
Peter,
Next.
I'm curious why, when you're calibrating for the true wind angle, sorry, for the apparent wind angle, do you want to kind of be in that slightly pinchy, squeezy mode with the jib?
Because that's going to give you the best resolution of, also, I didn't mention it, I think it kind of goes without saying, but it's important that everything be set up the same from side to side. You want to make sure that the lead's in the same place, and the mainsail's trimmed the same way on both sides, and it's sheeted the same on the both sides. It's going to give you a much finer, that the front of the jib is going to bubble it the same on both sides. If you're a little bit pressed, you don't know how much you're pressed. You might be pressed 3 degrees, you might be pressed 4 degrees. You don't really know until you get to that point when you can feel, you'll feel the boat just kind of unload a little bit. You see the front of the jib just start to bubble a little bit. And that's what you're looking for. It's just a feeling. And you can look at the telltales too, but a lot of times you'll just see it in the front of the jib before it actually shows in the telltales. And that's what it's going to give you the best indication of when that's actually happening. Does that make sense?
Yeah, that's definitely explains it.
And that's why that particular aspect of calibration works the best in 15 plus. It's hard to get a good apparent wind angle calibration in 5 knots breeze. It just is. It's almost, you'll never get it accurate. You'll get it way more accurate in 15 knots of breeze than you will in 5. So having, that's why you do it.
Okay, great. I had one question from the audience, whether you would take an optical boat speed sensor out during the week when you don't sail, or do you only need to remove paddles?
Yeah, honestly, I don't have a whole lot of experience with different other technologies of boat speed sensors than paddles, because every single time I've tried to use one, it doesn't work very well for me. They don't work well in really low speeds. Some of them work. The NKE one works pretty good when you're going greater than 4 or 5 knots, all the way up to whatever. They work pretty good above 4 or 5 knots, but sometimes you get really slow, they don't work so good. And consequently, I don't really recommend any other type of sensor than an old school paddle. And the best paddle to use is called a Signet. And it will overcome a lot of those boundary layer effects and nonlinearity problems that I was referring to. You look at all the basic Grand Prix boats, all your Med Cup boats are all running the Signet paddle. Nobody's running optical. It's pretty much always a Signet paddle, because it's pretty much the state of the art in boat speed sensors, to be honest with you. So that's why I don't really have a recommendation on that. I mean, I would think it would probably be better to take it out, but it may not matter. I don't really have a clear, I don't have much experience with those sensors, unfortunately.
Fair enough.
Yeah. And I don't, I think we pretty much covered instrumentation. I mean, that's pretty much all there is to it. It's essentially just a little system that's trying to resolve relative motion problems. It's essentially just trying to say, well, here's the earth, here's the water, here's the boat, and here's the wind. And you're trying to quantify all those things. Say, well, the water's going this way. It's SIGNET. You just got a question. Signet, and they're in Southern California. You can Google it. If you have a B&G system, you're going to want to use what's called the blue top, and some of them use what's called not many of them use a red top. But if you have any, I can take questions about it offline if you want. But it won't fit into the same through hull. Can you comment on wind speed error due to heel angle? Sure. So wind speed angle due to heel angle, the wind speed angle due to heel angle is resolved by changing the true wind angle. And so therefore, you're just forcing that to be right. I don't know. Here's what I'll tell you. Essentially, there is no real wind speed error due to heel. The biggest wind speed error you're going to find is due to the way the wind is affected by the sail plan going downwind. Going upwind, the transducer is in free air. It's in the front of the boat. It's getting the wind just hitting it. And it's not really affected by the breeze from the sail plan. Going downwind, however, that's not the case. What happens is the wind hits the sail plan, it accelerates the wind over the top right where the transducer is, and it causes it to read high. So there's another table in there. It's the true wind speed table. A quick down and dirty rule of thumb that will work a lot of the time is a 20% decrease in true wind speed going downwind. And so if you were to look at this table is also laid out in 5 knots of true wind speed. So it shows 5, 10, 15, 20, 25, 30. And you would put in -1, -2, -3, -4, or, you know, etc. to compensate. It'd be a 20% decrease in true wind speed as you go downwind. The true wind speed effect of heel is taken out by the angle table. So as you adjust the angle, it does adjust the wind speed, because if you look at the way the vector math works, if we force the angle to change, then it's going to change the resultant length of one of those vectors, which is the wind speed. The true wind speed is going to get changed, but it won't be inaccurate going upwind or reaching. It'll be inaccurate going downwind for sure. And that's why you need to correct it going downwind. One thing that will get affected by heel is boat speed. So there are also tables, and the other thing is 2 paddles. If your boat speed paddle is not directly on the center line of the vessel because the construction doesn't allow for it to be on the center line of the vessel, typically the boat speed will read higher on one tack than it does on another tack. There is a table you can use to correct that. There's also a different calibration factor. A lot of systems will have a port tack cal value and a starboard tack cal value. You're gonna do the base calibration with the boat not heeled, motoring, you know, going back and forth. That's your base calibration. Then, I mean, this takes a lot of effort, and it's not to be undertaken. It takes a lot of analysis to come up with actual heel correction tables for boat speed. You can pretty easily, if a transducer is not exactly on center line, it's on one side of the boat, you can pretty easily adjust. What you want to do is you want to adjust the leeward side. How do I put this? When it's on the leeward side, it's going to read slow, and you're going to want to speed it up. When it's on the weather side, you're going to want to leave that side alone, because that's going to be the side that's going to be accurate. The other side's not. I hope that that's a whole nother. There's so many different ways to deal there. You can put 2 paddles in and have it switch between one and the other. So we'll take questions like that offline, really. I mean, it's a pretty sophisticated problem, you know. There's so many ways to deal with it. Some guy just asked a question, but I didn't read the question in time, so I'm wondering if we could. Do they stay here?
Questions here for you? Maybe we can go through them.
Do that.
I think Buzz was asking about how to calibrate for downwind angles.
So you're talking about true wind angle corrections for downwind, and essentially it's the same methodology used for upwind and for reaching. You're just going to jibe. You're going to get your boat going downwind. You're going to do 10 jibes or 5 jibes or whatever it is. And, obviously you want to do it when the wind's pretty straight. It's not shifting much. There's not a lot of shear, not a lot of gradient. And you're going to be looking for a change in wind direction as you jibe. So if the computer calculates the true wind, due to miscalibration, let's say due to miscalibration, the computer calculates the true wind angle to be 4 degrees too wide, it's going to look like you get an 8-degree lift every time you jibe your boat. And so when you see that 4-degree lift, you're going to go, okay, my wind angle's too wide. I need to narrow it by half of the error. So if the error is 8 degrees, you're going to narrow it 4 degrees. So the methodology is the same. It's the same for going upwind and the same for reaching. For the reaching numbers, there's a couple different ways you can manage the reaching number. I usually set the boat up as in a pre-start configuration. So we're using a jib and we're just bearing off and going a 90-degree true wind angle and then tacking back to a 90-degree true wind angle on the other side. So you're going to go 90 degrees for a minute. You're going to tack, go 90 degrees that minute, look at the wind direction, and give it 15 or 20 seconds to settle out after each tack. But look at the number. Does it say lift or does it say head? Do it a bunch of times. And then whatever the error is, divide it by 2. If it shows a lift, you're going to make the number in the true wind angle table be more negative. If it shows a header, you're going to make it more positive. Same thing with going downwind and upwind. Next question.
There's a couple questions about speedos.
Yep.
Bob Walden asks, how far off center line before it really starts to matter?
It depends a lot on the shape of the hull. If like the TP52s are really flat, they got like a little pointy section in the front and then they really quickly get flat and go flat pretty far back, and it doesn't really matter. Some other boats got like a V thing, some of them have a chine right on the middle. Those boats, it makes a lot of difference, just a little bit. Like a J70 is a good example. A J70 has that kind of chine, and if it takes a pretty good skilled boat builder to put that thing right on center line. A lot of them don't, they don't come that way. You got to get a really, really good boat builder to put it right on center line, because if it's just a couple mil off, it makes a difference. You'll see the difference. But so that, I hope that answers your question. I mean, it just depends on the shape of the hull more than anything.
Do you have any advice on how to figure out whether you're slightly offset?
Yeah, I mean, just sail your boat. I mean, if you have some meaningful target numbers that you feel like you can attain, can you attain those numbers on both sides? Is it you always struggle on one side then the other side? And what side is the paddle on? I mean, the paddles generally 99% of the time, the paddle's going to read higher when it's on the leeward side. So if your paddle is on the port side of your boat and you're on starboard tack, that's going to be your fast tack. You're going to tack over to port. Now the transducer is going to be on the weather side and it's going to read slower. But that's how you tell if it's wrong. I mean, if you always struggle on one tack than the other tack, and you could even see if you're keeping track of the current, maybe the current changes. All of a sudden the current is not the same from tack to tack. If the current could not be the same from tack to tack to the leeway miscalibration, or the boat speed is not consistent from side to side. Generally, that's what's going to cause that.
Yeah, that's Bob thanks you. He says that might solve some of his vexing performance issues.
Yeah.
Joel was wondering, is there a benefit on planing boats to having a port and starboard paddle wheel farther aft, maybe even as far back as the sail driver farther?
Great question. So, yes. So Melch's 32. I put the boat speed transducer just aft of the engine room, about 18 inches outboard. So it's well after the keel. Volvo 70s, we put them pretty far back, almost like in front of the rudder, like way in the back. Yes, yeah, planing sport boats, you want it, ideally, you want your boat speed paddle to be where the most pressure is on the hull, which is kind of max beam. Once the boat starts to go back, get smaller, the pressure against the hull is less, and it's not going to read as accurate. Now with the Volvo 70, you got a big flat spot that's in the water and it just extends back. So you can go further out. It's not like it's losing a lot of volume towards the back of the boat. But that's a great question. Yeah, sport boats, the further back you can put it, the better off you're going to be by and large. But you do need to be careful that you don't get too far aft of max beam. If the boat starts to, if the buoyancy of the boat starts to drop off a lot right there, the pressure against the hull gets lower and the boundary layer extends out a little bit, and it can get a little bad when you're in non-planing situation.
Great, thanks. John Wilkerson wants to know what your thoughts are on short versus long wind wands.
You know, I'm not a huge wind wand guy, to be honest with you. I mean, and I'll tell you why. So the methodology we're using to make this right is essentially a wind table to force everything to be right by empirical analysis. You know, we're going out and doing a bunch of tacks and saying, oh, look, we're going to change this number until the error goes away. And we don't really care what the error is caused by. It could be caused by the Melch's 32, the wind, the mast rotate. Mast doesn't really rotate, but it like twists. Mast will twist. And you know, there was all this talk about, oh, how can we quantify the twist of the mast? And I was like, you know, we don't need to quantify the twist of the mast. All we got to do is make sure that our numbers are the same on both sides. And as long as the numbers are reading the same on both sides, we're taking the error out. We're forcing the error to be out, regardless of what is causing it. Now, having said that, if you're really out of range in your rig tune, that might cause an error. In other words, maybe now the rig is twisting more or twisting less because we don't have the rig set up properly. So then you're going to introduce some more error into it. But I think you can use the little horizontal sensor. You can use a wand that's short. You can use a wand that's tall. I personally like the shorter wand because it's going to have less VCG, less drag, less aerodynamic drag. And at the end of the day, your instrumentation is still going to be just as accurate because you're going to calibrate it to be accurate.
Serhad wants to just double check their understanding, assuming that the wind speed and direction is constant. When you're sailing downwind, will the measured wind speed be higher or lower than the actual wind speed?
It'll be higher. Yeah, with no correction, it will be higher because the way the wind hits the sail plant, it accelerates the wind as it goes over right where the transducer is. And the longer transducer will mitigate that effect, but it won't eliminate it. I've been on plenty of boats that had really, really long, you know, vertical wands, and you still get the same problem. It's just less.
Sarah says thank you. I don't see any other questions. One thing I've been wondering, obviously, the reasons we want to have well-calibrated instruments are basically to monitor our performance as we sail, and so we can build accurate polars. Maybe you can talk about how you go about building polars for a boat or refining polars for a boat.
Sure. Yeah, it's a good question. So you start with some sort of VPP number, which is essentially a designer has a piece of software. He puts in a lot of different parameters about the boat, and it spits out a polar. And it's a theoretical computer-generated base polar. In my experience, you can pretty handily exceed almost. I've never seen a boat that didn't really sail well. I did see one boat that didn't sail well to its VPPs, but generally speaking, every boat sails really, really well in comparison to the polar numbers that you just get from a VPP program. And so obviously step one is to make sure your instruments are calibrated, because you don't want to start doing a polar development or analysis with defective numbers, and that's pretty obvious. And I always branch them off too. I'll start with the base polar. The VPP number will be like V1. Also, I should say that you want to make sure you start with like a masthead polar. I always run masthead. Let me just briefly describe the difference between like a masthead polar and a 10-meter polar. A 10-meter polar uses wind at 10 meters above the water, which I never use. I always just use 100% masthead polars. And then I adjust my routing software, I adjust my 10-meter winds to match my anemometer, but that's further down. Let's just start with the polar. We're gonna talk about wind at the masthead. So when you get your VPP number, you want to make sure you're looking at a masthead polar and not a 10-meter polar. And if it's a 10-meter polar, then you got to scale it up or scale it down depending on how tall your rig is. So that's your base polar. And I was like, put like V1, V2, V3. Every time I change my polar and modify it, I give it a new name. And then sometimes I'll branch them off, like depending on the role of the boat. Sometimes you'll have an offshore, a boat that sails both offshore and inshore. So you'd want to have an inshore polar and an offshore polar, because boats can be configured differently, and it's generally going to perform better in the inshore configuration than it would perform in the offshore configuration. Furthermore, you don't want to look at sea state, because sea state has a huge effect on the polar. So it's going to be like, you know, in a program where I've done a lot of polar development, you would have this is my offshore, you know, lumpy polar. This is my offshore flat water polar. This is my inshore flat water polar, my inshore lumpy polar. You could make different polars based on sail configuration. Some boats, you know, you got different keels, got all these different things you got to think about. But by and large, you're going to start with that VPP number, and you're going to just gauge. Okay, so a couple different things you do. You want to adjust the speeds just based on whatever particular angle you happen to be sailing. And the other thing you want to do is work on your optimum beat and your optimum run. So there's essentially two different aspects of polar development. One is what's my optimum beat, what's my optimum is. Okay, well, now we're going to go reaching. So as soon as we start reaching, we just got to make sure that those numbers around those reaching angles are correct. A real easy way to kind of narrow in on your optimum beat and your optimum run is a variable called VMG percentage, which is essentially the percentage of VMG that you're making instantaneously over your target's VMG. And so if you're doing 105% of your target VMG, then whatever you're doing is better. You might be sailing higher at the same speed. You might be sailing faster at the same angle. Whatever it is, it's better. And you need to raise, you need to alter your target true wind angle and target boat speed to match that. And that's how you kind of, I call it just raising the bar. You know, you're always like trying to raise the bar on it, right? So this is the best VMG we've ever had. So now that's our new baseline. You can do that instantaneously by looking at those numbers. You know, if you look at a target true wind angle, I always put that stuff up on, I don't know. I feel like maybe VMG sailing is not really applicable to what we're talking about in the Pacific Cup kind of scenario, but it has a lot of value for sure in other types of racing. But that's kind of how you would do the VMG side. The polar side is the same thing. You could look at polar percentage, which is essentially the percentage you're doing of your polar boat speed. And if you're doing 100% or that your polar thinks you should be doing, you're doing 100% of it. And if you exceed it, then you need to raise that number out based on whatever your true wind angle is. And, you know, it just takes time and analysis and understanding the boat configuration is going to have a lot to do with it, and sea state's going to have a lot to do with it. So that's why I'm saying you're going to branch off those polars based on those criteria. I hope that helps.
You have a rule of thumb for how big of a difference in sea state you might kind of, let's say you're thinking in your head that you're adjusting a different set of polars.
Yep.
How do you make that division?
Well, it has a greater effect on VMG sailing than it does on reaching. It has some effect on reaching, but it has a huge effect on VMG sailing. I mean, as you know, when you're in flat water, you're going to get your best VMG performance. And anytime you start getting in lumpy water, you're going to have to bear off, and you're going to have to keep the boat rolling, and you'll be smashing into waves, and it's going to be slowing the boat down. And then it's just a matter of trying to quantify, well, where is my optimum beat or my optimum run in those conditions? And it just takes empirical analysis. You know, essentially, I think it's a little bit beyond the scope of what we're trying to do right here. I mean, there are tools in expedition. I use the strip chart a lot. You know, I'll go back and just go, okay, well, here we were sailing along. Everything was right. We had everybody hiking. We had it all set up. Where was my number? If I'm trying to resolve an optimum beat, where was my number? What's my VMG percentage? And, you know, you have, how do I put this? You just got to go out and do it. And you got to go up 2 degrees, up 3 degrees, hold that for a little bit, see what it does to your number. Press off, go a couple, 2/10, 3/10 faster, 2 or 3 degrees lower. What does that do to my number? And that's how you're going to narrow in on that number. And it just takes, analysis and effort, and then the key is obviously making sure that your instruments are calibrated properly. And we even talked about shear and gradient. I'll just briefly mention wind shear and wind gradient. Wind shear is the difference of the direction the wind is blowing as you move up off the water. If the wind twists to the left as you go up, that's called left shear. If the wind twists to the right as you go up, that's right wind shear. Gradient is defined as a difference in pressure as you move up away from the water. So in the ocean with swell, you see a lot of gradient just because the friction against the water is so much more due to the swell. You know, sometimes you go down in a trough and like there's not much breeze up there, and then you get up and all of a sudden you're back in the breeze again. You know, those two effects have a huge amount of influence on how accurate your instrumentation is. If there's, you know, you'll see it when you trim your mainsail. If you trim your mainsail with a really hard leech on one tack, but a really twisted leech on the other tack, you're probably experiencing a lot of wind shear. Same thing if you look at the Windex. If the Windex points like almost straight on one tack and then almost 90 degrees on the other tack, you're definitely experiencing a lot of wind shear. And in those conditions, you can't calibrate your instruments, and you cannot expect any kind of analysis you're doing is worthless. So I mean,
yeah,
yeah.
Makes sense.
Yeah.
Robert Johnson asks if the U.S. Sailing Performance Pack numbers, do you know if those are masthead polars or 10-meter polars?
Believe they're all masthead polars. Yeah.
And Bob was wondering what is good software to use if he has a NMEA log from a race for analyzing the performance and tweaking polars and things like that afterwards.
There's only two software packages that I personally have ever used. And one is Expedition, and there are tools in Expedition you can use to modify your polars that I would recommend if you're starting. That's probably where you want to start. And the other one is KND. KND is really, really sophisticated, has a lot of nice, really, really nice features, but it takes a fair amount of work to get proficient with it. So for that reason, I don't recommend it to a lot of people. You got to be pretty dedicated to making it work. But yeah, KND. It was the initials of the three people that built it. They're in Spain. If you do Sailing Performance, I think is the actual name of the software, but the KND is the name of the company. If you just Google it, you'll find it.
We have one person who actually raised their hand. So Greg Mitchell, I'm going to allow you to talk, and you can go ahead and ask your question if you're still around. I think you'll have to unmute yourself. Nope, maybe not still paying attention. Okay, it's a little after 8 p.m. Does anybody else have any final questions for Peter?
Can you go too far with corrections to the measured values with state-of-the-art instruments? So I'm not 100% sure I understand the question. When you say go too far, what I'm thinking you're suggesting is the granularity of the corrections. With the state-of-the-art systems, the WTPs, the Pharaohs, the Bravo systems of the world, you're not constrained. There's no constraints to your correction tables. So you can put as many rows or as many columns in your correction tables as you want. And that is a great versatility, but it also comes at a price that makes it a little harder to manage. And me personally, when I'm using one of those systems, I go to, in the lower wind speed ranges, I might use a two knot true wind speed granularity up until about 10. And then I'll go like 14, 16, 20. And I'm not even sure if I'm answering your question correctly. When you talk about go too far, I think maybe that's what you mean by you're kind of overthinking it and doing a little too much granularity with it. The systems put slopes in there for you for those, they interpolate those mid values. So if you don't have those mid values that they kind of go in those 5, 10, 15, 20, 25, 30 knot true wind speed ranges, that's going to be fine. for what you're trying to do in any non, you know, super series med cup type application, you'll be fine. You know, you're gonna get a good number. And I hope that answers your question. If it doesn't, let me know.
One more question. Do you have any thoughts on Garmin and limitations with those systems?
So there's things you can do to mitigate the errors of those systems, particularly if you were looking more in polar development and analysis rather than real-time numbers. You can, if you're running expedition, which I'm assuming just about everybody who's doing pack up is going to be running expedition, you can bring those numbers in and you can correct them in expedition and make them right. And it's under EXP cals. You go in there and go into instruments, and you'll see a little tab that says EXP cals, and you go in there and you can set in calibration numbers and tables. Even though those systems don't have tables built into them, you can do it in expedition, and then you can have expedition. You can look at the true wind direction on expedition, and it will be calibrated based on those tables that you're putting in there. And then you can do your analysis on that number. You don't necessarily have that on deck. In other words, the true wind direction you see on deck won't be corrected by that calibration, so it's still going to be incorrect. So you're going to essentially have a true wind direction on your expedition display that's going to read one thing, and you're going to see one on your instruments on deck, which is going to be another number. So for that reason, I would suggest, you know, if you're going to race your boat, you should probably have at least kind of an entry-level B&G system, and I don't work for B&G. I don't really push their stuff, to be honest with you. There's other systems out there that are just as good. Like the NKE is just as good, the Nexus, all those are just as good. Where the difference is being able to find somebody who understands it and can work with it and support it. Because B&G has a huge market share. So a lot of people know how to run it, and a lot of people know how to work on it. So that's pretty much their advantage. At the end of the day, the technology, the numbers that come out are very, very similar. I hope that answers your question.
Cool. Well, I don't see any more questions rolling in from the audience, and I see a few people have dropped off.
Okay.
So yeah, I hope everybody will send Peter their thanks. Really awesome to have such a total expert on all of this stuff.
If you come up with some sort of question at some point in the future, feel free to reach out to me. I'm happy to help anybody via text message, email, whatever. So
do you mind if I share your email address here?
Yeah, no problem. Yeah, blast it out to everyone.
Great.
It's all good. Yeah, happy to help.
So sorry, is it pksalenav@gmail.com?
That is it. Yeah, pksalenav@gmail.com.
Great. Yeah, well, thank you so much, Peter. Really awesome talk. And thank you to everybody who came and participated. And we look forward to racing against all of you in the Pack Cup.
All right. Good night,
everyone.